Okay, so question number 2, a particle is projected vertically upwards. So let's understand the situation. Let's see from ground, this particle is projected upwards, okay, with velocity. Okay, they haven't given you the initial velocity. The speed of the particle 2 seconds after it is projected is 5 meter per second. So the journey is like this. So when it is coming downwards, here somewhere, let's assume the particle is now here. So when it is here, then the time 2 seconds is passed, okay, and now the velocity is 5, okay. So what we need to find, the initial speed of the projection, so we need to find the u. So let's write down what are the given things. U is that you need to find, v is 5, time is 2 seconds, and the last thing that we would be needing will be acceleration. So as the body is in free fall, so the acceleration will be due to gravity. So g is going to be 10 or minus 10. So let's look into this, how we will decide for it. So because we are not going to take these two journeys separately, moving up or moving down, but we are taking this whole journey as one. So how to decide for the g value? As at the start, in the start of the journey, the body is slowing down because it is moving up. So if that is the case, then we are going to take the value g to be negative 10, okay. We'll always decide this from the start of the journey. So g is going to be minus 10. So we are going to use the equation of motion, v is equals to u plus at. Why we are not using the other two equations? Because we are not dealing with the distance or displacement, so we are using this one because we have also the time. So v velocity is 5. So how will it will be telling us that it is moving downwards. So if we are taking it to be moving downwards, that means the direction of it would be represented by minus. So minus 5 is equals to u plus minus 10 times, because acceleration is minus g, sorry, minus minus 5 is equals to u plus minus 10 times 2 seconds. So from here u will be equals to 20 minus 5, and that will give you 15 meter per second. Okay, so this is part A. Okay, so part B now. Part B says find the distance travelled by the particle between two times at which its speed is 10 meter per second. Okay, so the same journey, okay, somehow. So they say distance travelled by the particle between the two times at which its speed is 10 meter per second. So we know that the speed, now we are not talking about that time during which, actually we should be taking another diagram for this because it seems one second, because it is a different kind of journey representing. So a ball, the particle is at 10 meter per second. So when the body is moving up and when the body is moving down. Okay, so if we consider the two wherever the velocity, so once the velocity could be 10 when it is moving up, okay, and then the velocity will be 10 when it is coming down, okay. So we need to find the distance traveled between these two times during this region, this part of the journey, okay. So how can you do that? To do that, we can do one thing. Like we know when it reaches the maximum height at this point, the velocity is going to be 0, okay. So let's consider one more thing. We will be taking the two parts of the journey separately. So let's take when the body is moving up, particle is moving up, so it would be as we don't have time, so we are going to use and we need to relate the displacement and distance and the velocity. So we are using this equation, v square equals u square plus 2as, okay. So for when it is moving up, we are taking this part of the journey, so the final velocity is, let's write down the data for it. Velocity will be 0, initial will be 10, okay, and acceleration due to gravity. So now here in this part of the journey, if we are just taking one part, so the body is moving up, so it is slowing down or speeding up. So obviously if it is moving up, so it's slowing down, so a is g equals to minus 10, and distance we need to find, okay. So let's put in the value. 0 square is equals to, initial speed is 10 square plus 2 times minus 10 times s. So from here we get s to be minus 20s equals 100, sorry, minus not 20s equals to 100, and s will be equals to 5 meters, okay. One thing is this is for when the particle is moving up. Now when particle is moving down, so the same equation of motion we are going to use, v square equals u square plus 2as. Now look for the second part of the journey. If it is coming from here to here, then initial is 0 and final is 10. So initial is 0, final is 10, and acceleration due to gravity will be, now because now when it is moving down, so the body is speeding up, its velocity is increasing, so the g value will be positive 10, and s is that we need to find, okay. Let's write it as s1 and s2 because we need the distance between the two velocities, 10 and 10, okay. So let's substitute in the values. We will be getting 10 square equals 0 square plus 2 as, and s will be equals to 100 over 20. So it is also giving you 5 meters, so that means 5 meter up and 5 meters down. So the total distance would be between the two velocities 10 meter per second is 5 plus 5 meters equals to 10 meters. Okay, so this is all about your question number 2. This is part B and this is question 2 part A.